square roots in this problem. This is the radical sign. The radicand is the number underneath the radical sign. I'm looking for two numbers that multiply to make 4, and the number is 2. So 2 times 2 makes 4. Here we have two numbers that make 36. That would be 6. Notice these are both even numbers, so I'm trying even numbers. When they're odd numbers, try odd numbers. Two numbers that multiply to make 81 are 9 and 9. Numbers that multiply to make 121 are 11 and 11. Again, odd numbers, try odd numbers. Now, when you're looking at big numbers like 625, we need some benchmarks. So I'm going to end up using my benchmarks of 100, 400, and 900. These are good benchmarks. The square root of 100 is 10. The square root of 400 is 20. The square root of 900 is 30. I'm getting that because 1 times 1 makes 1 with 2 zeros, so that would be 10 times 10. 2 times 2 is 4 with 2 zeros, so that would be 20 times 20. So I see 625 is between 400 and 900, so I know the answer is between 20 and 30. When numbers end in 5, try a number that ends in 5. 25 times 25 ends up making that number. 225, well, that would be 15 and 15. It's smaller than 20 because 225 is smaller than 400, but bigger than 100. So in between those two numbers, 15 is the number. So when we have a fraction, you're going to treat it as two separate radicals. So take the square root separately. 5/9 is our answer. Over here we go with 15 over 13 as the answer. When we have a decimal, well, just try 0.8. Think of it as 64. The square root of 64 is 8. Well, the square root of 6,400, this is going to be 8/10. 8/10 times 8/10 moves the decimal 2 spaces. So this one would end up being 9/10. Looking at the next type of problem, and we'll actually go to these first, we're going to estimate the square root, and when we estimate, you think of perfect squares. So instead of thinking of the square root of 10, I'm going to start off with the square root of 9. That's a perfect square. That makes 3. Then I'm going to list the next few perfect squares all the way to the next perfect square. And so I list all these square roots here until I get to 16, which I know is 4. So I know that the numbers that are 13 through 15 would end up being closer to 4 than they would be to 3. So they're all in between 3 and 4. So they're 3 point something, but these square roots would be closer to 4. They would be, if I round to the nearest integer, about 4, where these square roots would be closer to 3. So the square root of 10 is going to be close to 3. Square root of 50, well, I look to see what the perfect squares are that 50 is in between. The square root of 49 makes 7. The square root of 64 is 8. So I would say the square root of 50 is close to 7. Here we're supposed to approximate to the nearest and then round to the nearest whole number. So we're basically taking a square root because they say the area of this square figure is 64 feet squared. Well, the square root of 64 is 8, and we're dealing in feet, so 8 feet. Where this one, when I take the square root, well, remember, 625 was 25, so this is going to be 2.5 meters. But again, we're rounding to the nearest whole number, so we're going to say about 3 meters in this case here. Looking at these last few problems, we are trying to name subsets. Subsets of real numbers. So real numbers, we have two different types. We've got a rational number, which has that word ratio in it. Ratio is a fraction or a comparison of two numbers. And so whenever I see rational numbers, I think of fractions. Irrational numbers, well, the prefix IR means not. So this is not a fraction. Numbers we cannot write as fractions. So numbers we're going to see that are irrational are going to be pi and non-perfect squares. So those are the ones we're going to look for. Well, underneath the rational numbers, we have other subsets. We've got integers that are special type of numbers, numbers that are on the number line. Notice how these all make numbers that we'll see on a number line. Whole numbers are like 0, 1, 2, 3, and so on. Natural numbers are like these. You see these reduced down to 5, this is 2, this is 7. Those are numbers that are whole but not 0, where whole numbers are all the even, or the not even, but positive numbers and including 0. So we look at this number, and this reduces down to 2/3. So this is just a rational number, where this one here is a integer and a rational number. All rational numbers can be written as fractions, and that's why I went ahead and showed you how that I could write this -5 as -5/1 to show you that that is a fraction, and it's also an integer because it's a number on a number line. So let me get rid of that extra r in there. There we go. And pi, well, that's one of our irrational numbers. That's a number we cannot write as a fraction. Same thing with the square root of 2 because it's not a perfect square. So that's what you're going to look for on tonight's homework. Good luck.